Permutation Prediction Part 2. So now that we have all of our numbers, possible permutations represented in algebraic form, we are down to Part C, where we are going to add these numbers. So what we're going to do is we're going to take the sums of each of these columns algebraically. And so we're going to combine like terms. So we have 1, 2, 3, 4, 5, 6 A's. And we have 2, 4, 5, 6. And we have that in each column. 1, 2, 3, 4, 5, 6 A's. 3 and 3 is 6. And in the last column we have the same thing. So this is what you have asked your person to do. Before I go to dividing by 6, I'm going to write what this means in terms of our place value. And so I'm going to do this using what we call expanded notation, something that you started learning about in 4th grade and continued through in your other grades. So when I look at the expression right here, I have to remember that this is hundreds. So I'm going to take 100 times 6a plus 6. I'm going to add it to 10 times 6a plus 6. And then, of course, this one is 1 times 6a plus 6. You'll notice that, and this is where factoring comes in, each of these expressions has a greatest common factor of 6. So I'm going to pull out that 6, and I'm just left with a plus 1 on each of them. So this is what we've been doing in our lesson last week, finding the greatest common factor and moving it outside, and then double checking to make sure whatever I have inside, if I were to use the distributive property, I would indeed get that back. And yes, I would. So I'm just writing these in terms of the factoring and using the place value. So you can see that now I'm left with 600 times a plus 1 plus 60 times a plus 1 plus 6 times a plus 1. So now this, actually up here as well, because I was adding these together, these represent my sums. Now I told my person to divide by 6. So when I divide the sum by 6, I'm going to come over here and divide each of these by 6. And I'm going to be left with 100 times a plus 1 plus 10 times a plus 1 plus 1 times a plus 1, which is just a plus 1. So you can see that in every single representative of the place value, I have a repeating digit. And that repeating digit is always going to be a plus 1. And when we look back, when we first assign the expressions to each of the digits, you can see that a plus 1 is always going to be your middle digit. So your first digit in terms of a, this would be a plus 1 minus 1, which is simply a, and this is a plus 1 plus 1. This one is 1 less than a plus 1. There's our a plus 1. And this one is 1 more than a plus 1. And algebraically, the reason that works is because down here we end up with the same digit. We're just multiplying it by the place value to get it in its correct place. And that, ladies and gentlemen, is the way to solve this algebraically. Now, another way to solve it is, this is referred to as an algebraic proof. This is an algebraic proof because we're using algebra. There's also another kind of proof, and that's referred to as proof by exhaustion. And proof by exhaustion means I'm going to prove this is true because I'm going to check out every single possible number combination there is, and I am going to make sure that it works every single time. So proof by exhaustion is another way to prove something without using algebra. But it can be exhausting. Harald, W/AO means without. It takes a long time, and you have to make sure that you don't make any small little errors as you're doing it.